Let's now talk about the pressure and temperature relationship, otherwise known as the Gay-Lussac's law. If you look in your notes on page 5, it states, Gay-Lussac's law states that at a constant volume, pressure is directly proportional to temperature. This means that temperature increases with increasing pressure and vice versa. Then we have this relationship right here. So as temperature increases, pressure will increase. As temperature decreases, pressure will decrease. And this will always result in a constant. If we know the pressure and temperature of a gas at a given volume and then pressure or temperature is changed, Gay-Lussac's law allows us to calculate the new pressure or temperature by applying the simple relationship that we see right here, where P1 over T1 is equal to P2 over T2. Let's see this law in action. So if we add some gas molecules to the chamber and we wait for the pressure to stabilize, waiting for it to stabilize, and then we go over to the constant parameter and we make volume constant. When we add heat, we see that pressure increases. So as temperature is increasing, pressure will also increase over here. If we change this up and we decrease the temperature, we now see that the pressure decreases. So as we decrease the temperature, pressure as a result will also decrease. Let's look at an example of the relationship between pressure and temperature. If the pressure of a gas is 2.3 atmospheres at 67 degrees Celsius, what would the new pressure be at 110 degrees Celsius if volume was held constant? The first thing that I'm going to want to do here is to convert 67 degrees Celsius into Kelvin. So I'm going to add 273, and as a result, I will get 340 Kelvin. I want to do the same thing to 110 degrees Celsius. So 110 degrees Celsius plus 273 gives me 383 Kelvin. Then I'll write my formula. P1 over T1 is equal to P2 over T2. Let's take the information given to us in the problem and plug it into our formula. If a pressure of a gas is 2.3 atmospheres, that's my P1. 2.3 atmospheres. At 67 degrees Celsius, we now know that is going to be represented by 340 Kelvin. What would the new pressure be at 110 degrees Celsius? So the new pressure is our P2, and that is what we are solving for, and my T2 is going to be represented by 383 Kelvin. So if I cross multiply and I solve for P2, I find that P2 here is going to be 2.6 atmospheres. Like we've stated before, it's always good to look at your answer and make sure that it makes sense. So we can see here that our temperature is increasing as we're going from 340 Kelvin to 383 Kelvin. As a result, our pressure should also increase, and we see that as we go from 2.3 atmospheres to 2.6 atmospheres. And this is a very brief example of a Gay-Lussac's law problem.